Hello, students. Had a couple questions on the isosceles trapezoid proofs. And so a couple pieces here again. A trapezoid with a pair of congruent base angles is what we call an isosceles trapezoid. So let's see here if we can't prove a couple of these, just so you kind of understand the idea. Each pair of base angles are congruent. Now this one says a pair, so as you can see, it's only one pair. So the nudge for that one, if you will, is to say if I know this, we'll just call this A and this one A because they're congruent. And then I can label these as X and Y. And then remember, we know because it's a trapezoid that the lines are parallel. If they're parallel, then A plus X has to equal 180 degrees, and that's from chapter 11. Angles on the same side of the transversal will sum to 180 degrees if and only if the lines are parallel. Then look on this other side over here, and we see that A plus Y equals 180 degrees. And once again, you could bring the A to the other side, and this tells you X is 180 degrees minus A, Y equals 180 degrees minus A. If X equals this, and using the transitive property, X equals 180 minus A, 180 minus A equals Y, that means X equals Y. So what that means is this angle up on top here has to be exactly the same as the angle right up here, even though we only knew that the other angles were congruent. So that's each pair of base angles. Let's see here, what else? Each pair of opposite sides are congruent. So now we're talking about sides. I think if I was going to do this one, this is where, again, I could draw it on this one shape, but I'm going to tell you, I think it's easier if you kind of recreate, so you have kind of almost two versions of the shape. So here's A, B, C, D, and then we know this angle here is the same as this angle there. That's what we know. So basically, these are the same. The reason why I'm saying put two pieces down is when I'm trying to make triangles to show that opposite sides are congruent. So I'm going to make over here, I'm going to go from B to D. Okay. Fair enough, right? And now from B to D, and over here, maybe I'll go from C to A. Let's see if that works. Okay. Phew. All right, so now let's see here. What else do I know? I may need these on top. I'm just looking at these first to kind of say, okay, well, what do I know from here? I know that's a trapezoid. So I know this angle up here is the same as that angle down there. Doesn't mean it was bisected. Excuse me. And I know this angle up on top here is the same as this angle down here. All right. Okay, so there we go. And I know this side down here is congruent to itself, right? And I knew the base angles were equal. Oh, I just thought of, I'm sitting here and I'm like, oh my gosh, I just thought of an even quicker way. But yeah, so this one right here is going to work great for this one. And here's why. Because, watch this. Let me get a thicker pen here. But what I want to show you is if the diagonals are congruent, right? Then I do have two triangles that are congruent. And that's A, D, C is going to be congruent to D, A, B. By side angle side. Actually, by side. Oh, angle side. No, see, we could do that with angle side because this angle down here is the one I want, right? And I know it's parallel. Hmm. Maybe I should go with the one that I was like, I had this cool idea. Okay, hold on. Let me see this. If I extend this up, watch this. Okay. Then this makes a triangle, right? Right. And the lines are parallel, so corresponding angles are congruent. So if I was looking at this, I really kind of have two triangles. One's kind of a short one on top, one's kind of a bigger one down below. The top one is isosceles as a triangle, which means those sides are the same. And then this bigger one, now take a look at this one as I do it. This bigger one goes all the way down, all the way across, and all the way back up. And its base angles are congruent, which means the long sides are the same. And so if you're trying to show that the pair of opposite sides are congruent, what you can say is, let's just say this short one here is x, the long one here is y, then this component right here is x, y minus x, because y is the big one. So this would be y minus x. And then on the other side, because the first triangle is isosceles, the length is the same. The big triangle is isosceles, that one's the same. So the length right down here would be y minus x, which means what? That these are congruent, that the opposite sides are congruent. So there we go. All right. So let's clear that off. So anyway, that takes care of the first two. And then if a trapezoid has congruent diagonals, then it is isosceles. Okay, so all I know now is it says it's a trapezoid. So I don't know these two pieces. So this is a piece that's tied to an isosceles trapezoid, but it's not specifically given. So if it has congruent diagonals, so if I go here and I tell you that this length right there is the same as this length right here, could I get, and remember it is a trapezoid, could I get that it is isosceles? They share two sides. I'm not sure if they share an angle. Hmm. Yeah, it has to be isosceles. So we're trying to prove that this length is the same as that length. I know red side is the same as red side. I know black side is the same as itself. And I know this side up here is the same as itself. Hmm. In order to be isosceles, I really just need the angles to be the same, the base angles. So I know this angle up here has to be the same as that angle there. We know that. And we know that this angle up top has to be the same as that angle down there. So that's all good. And then we have a number of additional pieces here. Right? Right. So let's put some labels in for those and see what happens. So I'm going to say the one up top here. So let's just say this one is A, the other one is B, the angle next to this one is C and D, and over here we have E and F. Okay, so what do I know? I know that A plus E plus F plus B is 180 degrees. And I know from the other side that B plus C plus D plus A is 180 degrees. So let me get rid of the A plus B on both sides. So I have E plus F has to equal 180 degrees minus A plus B, and C plus D has to equal 180 degrees minus A plus B. Okay, there we go. Okay, so that means by transitivity, E plus F is the same as C plus D. Now, do I have anything else? I need to connect A plus D being the same as B plus F. So B plus F has to be the same as A plus D. Okay, so let's see here. Can we show that A plus E, if A plus E is the same as B plus C, so A plus E is the same as B plus C. Hmm. Hmm. I thought there'd be a slick way to do this one, but I'm not seeing it right offhand. I wanted to do it with just the angles, but I think I'm going to have to bring the other sides in. All right, plan B. Go back to what I had initially, which is draw the two shapes. One diagonal here, one diagonal here. Okay. And let's see here. So I need to get congruent triangles. So I've got to have angles that are the same. Okay, let's do this. We got parallel lines with BC. BC is parallel to AD. We know that. Oh, that's horribly drawn. Sorry about that. BC is parallel to AD. So if we took, well, maybe this will do it. If we took the line like BD, right? And you put AC on here too, you could construct from here a line parallel to BD. Let's see if this does anything. So I know this one right here and this one right here. Okay. Yep. So what I've done is I've created another set of parallel lines, and I think this will do it. Here's why. I want this line right here to be parallel to this line here, so that when I cut it with a transversal, which is AD, this angle right there is the same as this angle right here. Okay. Why do I need that? Because when I built AC, AC is the same length as BD. So this length is the same as this length, giving me, I'm going to try to shade this one so you can see the triangle that I'm looking at. It's hard to tell in this a little bit. It's this triangle right here. This big triangle is isosceles because it has the two sides that are the same, which means the base angles become congruent. So this red, I should say, this red angle over here becomes the same as this red angle right over here. There we go. So now, again, a little bit messy, but I had to draw a new line to get an isosceles triangle. An isosceles triangle with parallel lines gives me this beautiful piece. So now I know these two are congruent. Now I'm going to go back to my general sketch, which is like right over here, and write down what I know. I know this angle is congruent to this angle. I know the diagonals are congruent. So red line here is the same as the red line here. And I know the base is the same. And that gives me one triangle that looks like this and one triangle that looks like that. And actually that second one was pretty bad. That looks like this. And I have this side's the same, this side's the same, and the angle down here is the same, which means these two are absolutely congruent triangles by side angle side. Therefore, this remaining piece on each of them must be identical. And if those are identical, right, then I have congruent triangles where I can say now, therefore, this angle here has to be the same as this angle here. And that is all we need. Because remember, a isosceles just has to have one pair of congruent base angles. So a red plus green gives me a red plus green. And fun. I guess you could have also done the triangles up here, this top left one with this top right one, because the diagonal's the same, the top side's the same, and now we know these two sides are the same, so by side, 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 their corresponding angles would be congruent, which would be the two angles at the top. Okay. What else could we do? Let's see here. You know one pair is congruent, right? So we just need one pair to be congruent. If we took, I wonder if we took the one that was obtuse, because if this is an isosceles trapezoid, then one pair has to have congruent base angles and one set has to be parallel. If it's parallel and they add up to 180 degrees, then what do we have? Either they're both perpendicular, right? Or they're not. If they're both perpendicular, you get 90s all over the place. If you don't have 90s all over the place, you'll have one that's acute and one that's obtuse. And what's great about the obtuse one is that if I do draw this angle here, and then I come down and I draw the same type of shape down here, and I say this with this line, what I have is A, S, S. It's ASS. But for the obtuse angle, obtuse or right, it actually does work. You will not have two cases. So obtuse, I guess that's big. See, now that sounds bad. Big ASS or SSA would actually work if it's 90 or bigger. If it's less than that, we have the issues. So as long as you're using the obtuse one, you could also get away with perhaps a little bit more of a slick proof. But yeah, that was good. You got to see inside my head as I was trying to do some work with just using the angles and trying to avoid making another set of triangles. And I just couldn't see how to do it. So it's possible that you can't do that, or it's possible that maybe I just didn't see it. Anyway, there's your isosceles trapezoid pieces. For that last one, that probably like drawing another piece over here that would be parallel to the diagonal here. That piece right there feels a little bit beyond kind of what some of the other proofs would be doing, so I probably wouldn't put that one necessarily on an exam. All right, off you go.